Okay, our first one, we're going to write an expression showing that 1 divided by 2, but without the use of the division symbol. How could I do that? What would that model look like? David? A fraction, kind of?
What? A fraction bar?
Yes, a fraction division bar.
Like that?
Yeah, like that.
Are you sure about it? Way to be confident, David. So, what can we determine from the model? Solo?
That you can use a division bar to represent division without using the division symbol.
Okay, I like that. You can use, I'm going to use a fraction bar instead of division bar. A fraction bar to represent division. Because we've hopefully you guys remember back, we taught you how to set up that division problem, right? So that you could find the decimal equivalent. We were changing from fractions to decimals, and we showed you how you do the division on that to actually make it a decimal. Can we now write an expression showing a divided by 2 without the use of the division symbol? What do you think, Willie? A over 2 with a fraction bar. So what can we determine from the model?
You can use a fraction bar even if there is a variable in the expression.
Yeah. We can use a fraction bar even if there's a variable. Okay? So when we write division expressions using the division symbol, what are the math terms? What do we call that A? What's the math term for it?
Variable.
It is a variable, but in a division problem, what is the first thing that is written?
Dividend.
Dividend? So then what is the second one?
Divisor.
How confident are you guys that that order is correct?
Very confident. Very confident. Very.
Yeah, I'm confident.
I'm confident.
I'm very confident. I'm confident myself.
Because you need to be confident in your answers. So we represent the dividend and divisor.
Is that order right?
It is right. Yes, good job. You got it in the right order. And you stuck to your guns, even more important. Because remember, I'm going to challenge you whether you're right or you're wrong. Otherwise, you'll know you're always right or always wrong if I'm asking you a question. So how would this look when we write division expressions using a fraction? So when I change this to a fraction, which one came first?
The dividend.
And the divisor came
Second.
second. So, or we can look at that as the numerator and denominator. Make sense? Question? We're actually going to be doing that quite a bit today. And I'll be honest, for me, it's actually easier using the division bar as parentheses than using the division symbol. And that's why we're doing both, to get you guys used to using that fraction bar as a division symbol, because as we're doing more complex operations with multi-steps, the fraction bar makes it a lot easier to separate them out. Okay, go ahead and turn the page. Okay, we actually want to give you guys a chance to practice. So we want you to do example 3 and all of these exercises. Real quick heads up, write each expression 2 ways, using division symbol and as a fraction. So that bottom part, you got to have it written twice. So we'll give you guys 5 minutes to work on this. No. So write an expression, guys. Please be quiet. A divided by B without the use of division symbol. That one should have been really easy, given what we just went through. write an expression for g divided by the quantity h plus 3. So there's two ways to do that. G divided by the quantity h plus 3. If you use the division symbol, which it didn't say you couldn't, you must have the parentheses on that. Okay? Write an expression for the quotient of the quantity m reduced by 3 and 5. So m reduced by 3 and 5. If you use the division symbol, again, the parentheses are a must. Otherwise, you would do the 3 divided by 5 first. Questions on that part? Okay, so the next part, you guys should have already done, so I'm just going to go through quickly. 12 divided by 4. 3 divided by 5. A divided by 4. Quotient of 6 and m. 7 divided by the quantity x plus y. Y divided by the quantity x minus 11. The sum of the quantity h and 3 divided by 4. And the quotient of the quantity k minus 10 and m. So a couple things I hope you guys noticed. Which one did I start with as I was doing this? Fraction. Any idea why I started with the fraction first? Solo?
So that you know how to do the equation.
Yes, especially when it comes to the parentheses pieces. For me, it works much easier in my mind visually to do it with the fraction bar first, because anytime, and you'll note as I mark the text, the divided, the quotient, that's when I start to realize mentally, here's my quantities. This is what I'm looking for. So when I see a number divided by a quantity, I know that that divided by is showing me where my bar goes, right? If I see really all these, the divided was in the middle. Quantity and quotient, here we go. So quotient is telling me I'm going to have how many numbers? 2, a numerator and a denominator, right? So at that point, I know I'm looking for some way that I'm separating those two. So I'm saying, okay, a quantity, okay, is telling me these are going together, k minus 10, so that and is showing me where my division bar goes. Make sense?
Yeah.
So if you'll mark your text, guys, and really, honestly, if you'll start in fraction form first, it makes writing it with the division symbol much easier. Because I'll be honest, if I were just to start writing it with the division symbol, I would have to go a lot slower because I'd have to contemplate where those parentheses go. But if you do it with the fraction bar first, then writing with division symbol is a no-brainer. Literally, wherever the pieces are together that I need to put together, that gets your parentheses. Does that make sense to you guys? Anybody struggling on that piece? Okay, let's go ahead and turn the page. There's your first part of the homework. This is page 63. So rewrite the expressions using the division symbol and as a fraction. So you have two ways to write each of those. Okay? Not hard. And then draw a model to show that x divided by 3 is the same as x over 3. So if you just show your model, it shows where your dividend and divisor are. Pretty easy? Okay. We're going to hand out a packet real quick, and we're going to do the rest of today's lesson out of this packet. Okay, so the first part of this is we're going to give you guys some steps to be able to walk through. This is actually a step-by-step. If you'll follow these steps, it's going to make it far easier for you to take the words and turn them into algebraic expressions. we've got an example here to walk along with us. In our example, can't quite see it.
Hold on. Let me see if I can move it.
Thank you. Okay, we have $8 more than Ryan earned. Thank you. Okay. Step 1, use only the most important words. If you're marking your text, those important words are standing out. That's really the idea behind marking your text, guys. Get those key numbers and words pulled out of the sentence so that you're sure to incorporate all of them into your actual answers. So in this case, what did we look at? We said 8. We said more, and then Ryan earned. So really it's both those. Those are the key terms that we need to make sure are expressed once we actually write our algebraic expression. Next, we need to choose our variable to represent the unknown quantity. So what variable would we want to use for this?
X.
X. I agree with that one. I like X a lot. Now we have to say what X is. So what is X?
Unknown.
Right, but what is it that we don't know in this problem specifically? Sean?
What, Gary?
Yeah, how much
did Ryan earn?
I want one more piece.
Dollars.
Dollars. Remember, be as specific as we can. So what Ryan earned in dollars. The more specific you can be as you're identifying your variable, the easier it's going to be to include the variable in your answer, but more importantly, the more information you get as the variable is solved for. You'll know exactly what it is. So including units is really important. What did we call this? What was the mathematical term we used for this?
Variable.
That is your variable, but this process, what did we call this? This was actually one of your terms from first quarter. This is why we requested that you keep a hold of your old modules, because it's actually in your notes.
Defining variables.
There you go, defining your variables.
Just found it.
You found it?
Yep.
So it was in your notes, right?
Yeah, defining variables. Before defining variables, label it so you know what it represents.
Excellent. Well done, Devin. Thank you. So that was actually in your math notebook? Did you do them in the math notebook the whole time, Devin?
Yeah, I didn't put it in my...
Okay. That's actually kind of nice. That's why historically I've always had them do a math notebook, but when we went to these modules, it was just one extra thing for a lot of people to carry around that they didn't want to. Okay, step 3. This is kind of an optional step. Okay, it can help us visually understand how to solve problems and how to set them up correctly. You don't always need to use it, but it's still important to understand, and this is modeling. So if we do a model on this, what does my model look like? Hayden? So, you want to give it a shot?
So, a model would be, so you got a rectangle,
Okay.
and then
What goes in the rectangle?
X.
Okay. Then what else? What else is happening?
And then next to the rectangle, you make another one, and then add 8. Put 8 in there.
Okay. So it's because it's less than 10, we'll actually draw 8 boxes because we're adding 8 to it. So remember, that's kind of our rule of thumb. If it's under 10, we'll do individual boxes for it. Once we get to double digits, then we can just do a second box with the number.
You really hate that, don't
I wouldn't say I hate it,
you? That's my rule.
but it's a heck of a lot easier just to do another box with an 8. Okay, now I can, and this is why the models can help us. From here, it should be super easy to go to my actual algebraic expression, right?
Yeah.
What is it?
X plus 8.
Now, I want to just step back real quick. Why did the 8 come second if it's first in the writing?
Because we're adding the 8 to the x.
So I can't do 8 plus x?
Well, you can because it's a commutative property of addition, but that's just how I said it.
So why did I say this is the correct way to write this when the 8 came first?
Because
it's more than Ryan, or not how much Ryan earned more than 8.
Yes. It's that more than, that flipping phrase. More than reverses the order of it. Make sense? Any questions on that? Okay, so let's try to apply the steps above to the following problems. Be sure to define a variable, then write each phrase as an algebraic expression, solve if necessary. Helpful hint, models can help you visualize. So the models can help you visualize the problem. Marking your text will also help you immensely on these. So our first one, we have 4 points fewer than the bull score. So what is our variable? What is it we don't know? Caden?
Don't have the bull score.
What about the bull score?
There.
Okay, so x is number of points, the bull score. Again, be as specific as possible in defining your variable. It's going to help immensely. So, what does our model look like? 4 points fewer than the bull score, yes?
A box on top, and then a line going to a box.
Okay, what's in the box on top?
X.
X. Then a line, and then what?
A line down leading to 4 more boxes.
4 more boxes, good. Does everybody understand where we got the model from? So then what does that look like as an expression? Everything, Andrew? How would I write that as an expression now?
Is that for me?
Mm-hmm.
X minus 4?
It is Andrew, right? Yeah?
No, it says here his name is Logan.
Well, no, that's why I can't trust those tags anymore.
I can't.
You can't see his tag anyway.
Don't start with me.
Number 2, the total cost of a shirt and an $8 pair of socks. What is our variable? What is it we don't know?
Total cost of the shirt.
Total cost of the shirt?
In dollars.
Good, thank you for that addition. So, do I need total in there?
No.
No. Really, it's just the cost of the shirt in dollars. Whoa. I didn't even see what all happened there, but that was fun. Total cost of shirt in dollars. The total is important because that's telling us the operation for our model. So what is our model look like? What do you think, Roland? What came first? Which is what? X. So our model, we have X. Total cost means I'm going to do what? What operation? Addition. So what's going to come after the X?
8 more boxes.
8 more boxes. 1, 2, 3, 4, 5, 6, 7, 8. So what does our expression look like? Lonnie, can you turn that into an expression now? Lonnie, can you turn that into an expression? Yeah, it's that easy. If you'll look at the models and you understand what the models look like, guys, turning it into an algebraic expression is really easy. That's why we have that helpful hint Those models help you visualize what your algebraic expression is going to look like. Okay, our next one. 12 times the number of feet. What is our variable? What is it we don't know? Caden?
Number of feet.
Caden? What is it we don't know?
Of the number of feet.
Number of feet. So x equals number of feet.
X equals the number of feet in feet.
I think we've talked about feet and then dropped off feet.
Oh yeah, we had a really wild sidebar in A1. I don't think you even knew that one was. What does our model look like? So?
12 next to X. No? No.
Not for the model.
Oh.
How do we do multiplication models?
So, you do 12 boxes and then put an X in all of them?
Good. Remember, multiplication is just repeated addition. So I'm taking my 12 boxes and I put an X in each one of them. Now, how do I write that expression?
Wait, 12 times X.
So how do I write that?
Oh, wait, wouldn't it be X times 12?
Which way is it?
X times 12.
Does it matter?
No, but the correct way is X times 12.
It is. So X times 12?
No, put a dot, put a dot, put a dot.
Just like that, Devin?
No. Yeah. Except for the multiplication sign is a dot.
Oh.
It's like double variables.
Doesn't it? It did look like double variables, didn't it? So is everybody okay with that? Uh-oh. Gian, you're saying no? Why not?
It's not X amount of groups of 12. It's 12 groups of X of the variable.
Wait, that's what?
So you're saying, I'm not modeling X numbers, X groups of 12 here, am I?
Oh, no.
It's 12. It's 12 times X because it says 12 times the number of feet.
Does it really make a difference?
Because it's going to be
Yeah, it does.
I mean, it does.
The answer is the same because of commutative property multiplication. Good job. You need someone? Yes, we have several of them. For Avin to Starbucks? Oh, you're all the way from over Mr. Hess?
Yeah, I'm in 7th grade.
Okay. Yeah, you may borrow one, but we need it back at the end of the period, please. Okay? So, yes, it does matter. When I am writing a multiplicative algebraic expression, I never put the variable first because I don't know how to model that. I don't know how many groups of 12 I can put in there, do I? But I do know how many groups of X I need to put, don't I? Because we call this number a special name. What do we call that? A numerical term in a multiplicative algebraic expression is called a...
Isn't this in my notes?
It should be. We've already had it in our notes about 4 times now. You guys still have not gotten this term down. Nope, the variable is the X. What's the number piece called?
Coefficient?
Oh, Devin. Devin's on fire today, man. Devin's actually using his notebook. It's amazing. It actually works. That is called the coefficient. Wow, it's almost like we gave you notes that had a purpose. Wow, who would have ever thought of that? Had to be Miss McShank, 'cause it's a good idea.
Nice.
Trying to brighten your day a little bit, Miss McShank. Okay, our next one. 10 more than 2 times a number. So what is our variable?
A number.
So what do we want to use?
X.
X. And X is
Number.
a number.
A number in numbers.
What does our model look like? Someone other than Devin. What do you think, T? What's our model look like? 10 more than 2 times a number. Yeah, you do. Break it down. You can. 10 more than. What is that telling me? What operation? More than is addition, but more than tells me something else, doesn't it? Tells me flipping. So what's going to come first? 2 times. How do I write that? 2 times a number. So what? Just one? 2 X's in boxes? So I have 2 X's in boxes. And then what? 10. And now we're into double digits, so we can just use a box with a 10.
Wouldn't that be the other way around?
More than is a flipping phrase.
Oh,
Right? Now, technically you're correct. Commutative property of addition, I'd get the same answer. But if we're being true to the writing, more than is a flipping phrase saying that 10's coming after the 2 times a number. Make sense? Question? She said double digits. That's the McShann rule. So happy. Yes, Ola.
Is there a mathematical word in the answer to a subtraction problem? If there's a
Difference.
difference,
You're welcome. Okay, our expression would be 2x plus 10. Okay?
can you do 10 plus 2x?
You can, because of commutative property of addition, you get the same answer. But if I were truly representing this phrase, it needs to be written this way. Okay? And that's why I don't like the wiggle room they give you with the Engaged New York curriculum. Yes, they are equivalent, but if I am really translating this correctly from English to math, my order should follow. Okay, go ahead and turn the page. So we've given you an example, gave you an algebraic expression, the word phrase, and a model. We want you to do the same for the next 3 to give you more practice in writing each of these. Quick hint, you may not pull out your old notes on this one.
I don't even have my own notes.
Our first one. How did we say this one in words? So? The words, yes.
The difference of a number and 4.
Awesome. The difference of a number and 4. What does our model look like? John? Okay.
And then put a box part of the V and put 4 boxes.
Like that?
Yeah.
Sweet. Well done. Wow, Mr. McShann's video is going on overdrive today. I can't even switch my pen.
Yeah, this should.
When you're mean to me.
Mean? I am nothing but kind to you. Maybe sarcastic once in a while, but still kind. See, look at her smile. Okay, the second one. What is this one? How do I say this one in words? What do you think, Sean?
The product is 5 and a number.
Awesome. And what does my model look like? Billy? Good. 5 squares, all of them have a W. And our last one. Lydia? Quotient of 3 and a number.
Wouldn't it be a number in 3?
Would be a number in 3. Remember, my dividend or my numerator has to come first. So what does the model look like? And this is what I heard a lot of people questioning. It's just the C, the 3 on the bottom with a circle around it showing I'm dividing that C into groups of 3. Make sense?
Yeah, do you have to have a circle? Yeah.
Yeah, the circle shows the division. There's another way to do the model. It's called a partitive model, but I don't want to confuse you guys by doing different models. Although the look on Ms. McShann's face makes it much more interesting, maybe I should do it.
Yeah,
Okay.
You can have one.
We're going to give you guys an example and then let's set you free on this piece. So our first part, again, marking our text is important. Half as many pages as George read. So what's my variable? What is it I don't know?
The amount of pages George read.
Good. So X is number of pages George read. What does my model look like? Half as many as he read. So I have my X and half. 2 boxes. My algebraic expression, X over 2 or X divided by 2. Technically, I could also rewrite this as 1/2 X. So any of those 3 would be acceptable. Make sense? You understand what we're doing on this part of it? Okay, so we'll give you until lunch to finish up this page. So work right up to the lunch. So marking the text again helps us, because if I mark the test, we now know what it is I don't know, which is
The width of the box.
the width is what I want to find out. What I don't know is the length. So X is length of the box. Excellent. I'm glad you added the inches. In inches. Okay. Our model, so I know I have my box. Less than is one of those flipping phrases. So 4 inches less than that length. Put the 4 below it, meaning my model, or my algebraic expression is just X minus 4. Our next one, cost of 5 CDs and a $12 DVD. What is it I don't know?
The cost of 1 CD.
Good. Cost of 1 CD in dollars, because again, be as specific as possible. What does our model look like? I have 5 of them and a $12 DVD. So my model is
5 X's and then 12.
because we've reached our magic double digits.
What about triple digits? Then can you still write out the number? No, if you write 12.
No. Anything above double digits, you get to write the number. So, our model, decimals, you pretty much have to write in a box anyway, because you can't really do boxes on decimals. You can, but it gets a lot more difficult. Avocados are double the price of oranges. So what is it I don't know?
The price of an orange.
Price of the oranges. Remember, you got to think of it in terms of what don't I know, not what I'm trying to find. So X is price of oranges. Can't do both. I'd need 2 variables if I'm doing both.
In dollars.
Doesn't give us a unit on this, does it? So I actually wouldn't make an assumption. So just price of oranges, we don't really know in what. Double means what? Twice. Students sit in groups of 4. That tells us what? X is the number of students. And groups means we're breaking them into even portions or dividing. So I'm taking by X, dividing by 4. Just circle it. And my expression, x divided by 4. Everybody good on those? Who said no? Is that you, Stella? Layla? Which part's confusing to you?
Oh, that's not what I mean.
How can you not be done? I already wrote it.
Because some people don't pay attention.
Well, not everybody is you, Isaiah. Okay, our next page. We'll let you guys get some more practice. So pay attention, break them down by the variables. Are you required to do models on these?
No.
No, but remember our hint, sometimes the models help you visualize it. So again, probably will be because we've only got 20 minutes left. I don't know that we'll get through everything.
I've already started.
So I'm going to try to give you guys about 10 minutes to do this page. We'll go through it, and then we'll do as much of the last page as we can. Okay, we're running out of time, so we've got to go through this pretty quickly. So the Johnsons, and guys, and I'm going to stress this again, especially in these type of word problems. If you mark your text, it's going to help you out immensely because all of this important information is going to start to pop out and make it easier for you to understand what you're supposed to be doing. Okay? So the Johnsons bought a box of popcorn and for $3.50 and 3 medium drinks. So define a variable, there's a task, write an expression, there's an additional task to represent the total amount they spent. So the variable, when you're circling the numbers, the variable becomes very easy. What is it I don't know? Billy? Cost of the drinks. So my X is dollars for medium drink. And it also helps to mark your text because I can see everything that needs to be included in my expression. I have the 350. I know that I'm looking for a total cost, meaning I'm going to add, put the pieces together. How many of the medium drinks do I have? 3. 3x. Should be that easy. Find the total amount they spent. One drink cost $1.50. So now they just gave me the answer for my variable. So now I can solve my expression. 3 times the $1.50. Order of operations says do multiplication before addition. So I'm doing 350 plus 450, which gives me a grand total of $8. Okay, our next one. Whoa, what happened? I skipped. Nope. It just erased? Oh, the paper moved down.
I used the force.
Okay, I see what happened. It's like, what the heck? Yeah, the paper moved instead of the board. Okay, U.S. House of Representatives has 35 more members than 4 times the number of members of the Senate. Define a variable. There's our first task. And write an expression. Second task to represent the number of members in the House of Representatives. So again, here's your key. If I'm trying to find the House of Representatives, what I don't know is the other piece. Okay, because you're always defining your variables in terms of what you're trying to find. So in this case, my variable X is number of senators, or numbers of members of the Senate. My equation, 3 more than, that's a flipping phrase telling me I need to flip it. 4 times my variable, so I do my 4 times my variable and add 35. Now they say find the number of members in the House of Representatives if there are 100 members in the Senate. So basically, we now know what my variable is. 4 times 100 plus 35. Order of operations, I multiply 4 first. 400 plus 35, or 435 members of the House of Representatives. That is actually right. The hard part is that hasn't changed in almost 100 years now, so they're far less representative than they were ever designed to be. Okay, number 8. Terry bought a magazine for $5 and 2 bottles of nail polish. What is the total amount she spent if a bottle of nail polish costs $3? Define a variable and write an expression. One thing I don't like about this problem is they already gave it to you. So that made it a little harder because you had to think about what I didn't know. In this case, it should have been cost of nail polish in dollars. And my expression, I had the $5 for the magazine and 2 bottles of nail polish. Like I said, it made it harder because they gave it to you all in one piece. So now my total cost spent on the magazine and nail polish. So that's what we're trying to do. I now have the $5 plus 2, and here's where the information they gave me comes in. Order of operations, I do the 2 times 3 first. 5 plus $6 for a total of $11. And I don't know how I keep doing that. That is funny. It is pretty magical because I can't do it intentionally. Okay, Alex ate 4 less than 2 times the slices of pizza that Oliver ate. Oliver ate 8 slices of pizza. How many slices did Alex eat? There's my question. Define a variable and write an expression to represent the total slices that Alex ate. So what is my variable? Nope, that's what I'm trying to find, meaning that what I don't know is what Oliver ate. So X is number slices Oliver ate. Oliver. Okay, my expression is 4 less than. Less than is again one of those flipping phrases. 2 times, so I have 2 times my variable with 4 less than that. 2x minus 4. Determine the total amount that Alex ate. Now I can put it into my expression. So that's where I'm going to use that Oliver ate 8 slices. Order operations, multiply first, means that Alex ate 12 slices. Is this all making sense? Okay, we only have a couple minutes left. So your first page of homework was page 63 in your module. Your second page is this one. Should be relatively simple. It's quite a few problems, but they shouldn't take you long. Difference of a number t and 22. Difference means subtract. The one to be careful of is these flipping phrases. Added to is a flipping phrase. M and 18 means I should switch that around. Does that make sense?
Is it still correct if we don't?
Technically, because of commutative property of addition, we would give it to you on that one. But if it's a less than or subtracted from, then your order does matter and you've only got one way. So get used to doing it correctly every time. It will make it better for you when it really matters. Because if you can be very specific every time, then you don't have to worry about it. Make sense? Any questions?
Yeah, I am.
No questions?
Well, I have one.
Yes.
Did you write this out, or did you, like, get printed?
Did you make the problem?
Technically, this came from Miss Caruana, my partner, the last couple of years.
I had 12 watermelons.
Yes, David? Can't hear you. I will. Next class.